Hello class, thank you for joining today's lesson about word problems. I hope everything's going alright. And just remember, if you guys have any questions about anything, whether it be from last week or from this lesson plan afterwards or just anything in general, you make sure you guys know you can ask me for anything. So today we're going to be going over different ways we can look at word problems and different strategies we might use for that. And so this week's strategy would be using a type of graph. So we've learned about word problems before, and we all know about what word problems are, I'm certain. Especially, not even in school, but outside of school. If you've ever been asked to divide something or split something, if you're in a group and you want to split something equally, you have had a word problem and you've had to solve that word problem. So today, the different types of graphs, we're going to be looking at three main types of graphs today, and then we'll do a short little just assessment/quiz. I'm not really going to take it for a grade, but it is something that we could use later on as a grade if I feel like we're not understanding the information as well as I might like. So for the first one, it says it's going to tell us how to use a line graph. So a line graph is any type of graph where it's just a straight line that goes up and down or back and forth. And so what it does is, we're just going to read it here. Line graphs are used to track changes over short and long periods of time. That's something you might want to write down in your notebook just for future reference. So line graphs are used for changes over short and long periods of time. Like, say, for example, if you had a word problem about temperature, you might make a line graph over a week or a month. And so one day it's pretty cold and we're going to say it's 50. So for day one, you'd make a graph with your x and your y axis, which we've kind of been learning about. Not really, but we'll definitely be practicing that today, where the x axis will be your horizontal, your left and right line. And we can call that day 1, day 2, day 3, all the way up to the day that we want to stop on. And we'd have a y-axis going up and down a vertical line. That would be a series of numbers that will represent our temperature. So for day 1, let's say it's a cold day, cloudy. We'll put the temperature at 50 is what we observed. So you'll put a dot connecting day 1 and the 50 temperature. Day 2, the cloud's gone, the sun's out, and it's a bit warmer, so we'll say it's 80. So we'd make a dot then on day 2 and 80. And then we'd make a line from the first dot from day 1 and 50 degrees to day 2 and 80 degrees to show that correlation. Then day 3, it's still pretty hot, but it's not as hot, so we'll say it's 75. So again, we'll do day 3, 75 degrees, we'll connect those, then we'll connect a line. So, and we can do this so on. Day 4, let's say it'll be 90, day 5, 60, day 6, 60 again. And so at this point, we're going to have a line, and we'll be able to see a relationship of a change in temperature over a short period of time. And this can go on forever. For a pie chart, we'll just read that pie charts are best to use when you're trying to compare parts of a whole. They do not show change over time. So this is probably the opposite of a line graph, because even if we were to show a change over time, we wouldn't be able to do that in a pie chart. What pie charts are good at is understanding like percentages of things. So it could be like if you're going to sell chocolate bars, and we'll have team 1 and we'll color code them just so we can better see. We'll have team 1 will be red, team 2 will be green, and team 3 will be yellow. So we'll say team red sold 30 chocolate bars, team green sold 24, and team yellow sold 35. So we'll put that in a pie chart and we'll shade in that amount. So even if we weren't asked how many did each team sell, we could, even if we weren't told that, we could see based on the color shading that team 3 had sold the most based off the amount of shaded area. Seems like to be the biggest amount. So pie charts are good when looking at wholes like that. So if we're going to split a pizza, pie charts are good for looking at if you're going to split a pizza into eighths, you'd have 8 different little pieces of pizza. like a pie chart, where if we cut half the pizza in half and the other half we cut it in fourths, we then have two on the half side, we have two lesser slices of pizza, or two bigger slices of pizza. Then on the side where we cut it in fourths, we'd have smaller slices of pizza. So it's good for, like it says, when comparing parts of a whole, whether it be a pizza or counting a certain amount of people or items. A bar graph can be considered similar to a pie chart, because we're also going to be, we'll read it here. Bar graphs are used to compare things between different groups or to track changes over time. So it's similar. It's kind of like in the middle of a pie chart and a line graph. It can do both things, but it can't do everything that a line graph could do or that a pie chart could do. So bar graphs can show a change over time, because again, it's going to go into an x and a y axis, some of the line graph, but now instead of making a line, we're going to typically be comparing number values going up or down. And I can, when we get into the activity, I'll definitely try to show you guys an example of that. So we could have something like a pie chart, which is the same example of selling chocolate bars. We'll have team 1, team 2, and team 3 on the x-axis. And like we said, we can color code them. Again, red for team 1, green for team 2, and yellow for team 3. And so we'd go put a number on the y-axis, and we can do it on a count it by 5. So we'll go 5, 10, 15, 20, 25. So that will help us to save time, so we're not having to write out 1 to 40. And then we just make, you could say like a skyscraper, from the bottom of team 1 up to, I think I said 24 chocolate bars they sold. So you're going to make a skyscraper, you're going to shade it in from 0 to 24 team 1. And I think I said 30 for team 2. So we'll make a skyscraper from 0 to 30 for team 2. And for team 3, I think I said 35. I do forget, sorry about that. And we'll just shade it in from 0 to that number, and we'll color code it, so again we could better visually see it, because sometimes if we colored it in one color, it can be kind of harder in our brains to understand what is happening here. So those are different types of them, and you can definitely search it up on the internet, but for now we're going to go into an assessment, and I've made these assessments to, first we're going to ask the question of what type of those 3 graphs should we use. So it's important to understand what is the question asking when trying to figure out what type of graph should we use between a line graph, a pie chart, and a bar graph. So, like I said, line graphs and pie charts are very different, so we're not going to use them for the same question. Secondly, once we figure out what graph we're going to use, even though we might be able to do some of the math in our head, it is still important to be able to write down and draw these types of graphs to better be able to visually see what our answer is, which will help us find our answer again. And it's also good for showing work. For when I do ask for that work, this is what I'm really asking for in a word problem, would be to see what, did you figure out what type of graph you're supposed to use, and then did you draw that graph to better be able to show. So, like we've learned when we're going over these word problems, what's important is to, 1, like I said, ask what is the question asking, and then 2, underline what you think is important and try to figure out what is not important. So, when we're going to read this, we're going to try to figure out what's important and what's not important in this word problem. So, to read it, it says, 3 students decided to see who can run the most laps around a track. Carl ran 9 laps without stopping, and Sadie ran twice as much as Carl. However, Phil ran a third of what Sadie ran. How many laps did Phil run? So this one, it's pretty simple to figure out what the question is asking. We're trying to figure out how much Phil ran. So what we're going to be doing is it seems like we're going to be comparing Carl, Sadie, and Phil's laps. So this doesn't necessarily show a change over time, does it? So we won't be using a line graph for this one, because there's not a change over time. If this was just about Carl and what Carl ran day 1, day 2, and day 3, that's a change over time. But we're comparing different values between 3 different things. So we're between pie charts and bar graphs. So because it wants to know how many laps did Phil run, I think it would be best to use a bar graph instead of a pie chart, because we're not really comparing a whole, are we? So I think it's best we used a bar graph. So first we'll have Carl, and you can make him any color you want. You can make him red. And so it tells us straight out of the question that he ran nine laps. So for Carl, we'll put Carl down the x-axis, and we'll worry about our y-axis a little bit later, but we can just write down a 9 now until we figure out a bit more information and figure out how big should we make our y-axis, because sometimes we can make them too small or too big. So it says Sadie ran twice as much as Carl. So if Sadie ran twice as much, then what kind of operation are we doing? Yes, if you said multiplication, that's right. So what we're going to be doing is we're going to be doing 9 times 2 to figure out how much Sadie ran. And we should know, if we're still practicing multiplication charts, that 9 times 2 is 18. So we can put Sadie's down as 18. And you can just write that down in the bar graph above Sadie. And if we keep reading, it says Phil ran a third of what Sadie ran. So because we understand that a third means what kind of operation? The opposite of multiplication? Yes, we will be dividing Sadie's by 3, a third. So we're going to be doing 18 divided by 3. So I know a lot of us aren't as comfortable with dividing, so you can use your strategies of repeated subtraction, or where you try to reverse multiply. And so you can say, what times 3 gives me 18? And knowing multiplication again, we would know that's 6. So based on that, we would know 18 divided by 3 would be 6. So now that we have our 3 numbers, that does answer the question of how much did Phil ran. We just figured out that Phil ran 6 laps. But still, to show our work, it'll be good to fill in the rest of our bar graph. So what we'll do is, now that we have our scale of 18 as the highest, we can make a scale of 0 to 20. And then just shade in a skyscraper of 0 to 9, and then 0 to 18, and then 0 to 6 for the 3 different of Carl, Sadie, and Phil. And that'll be just what I'm looking for showing our work. So on the second one, I'll read, Tom is having a problem attempting to figure out how many plates he will need for his party. Tom sent out invitations a week before, and 10 different families said they will attend. 3 of the families said they will bring 2 other people. 2 families said they will bring 3 other people. 5 of the families said they will bring 4 other people. And 1 family said they will bring 5 other people. What Tom is asking is if you could help him figure out the total number of people. So I know this is a lot of information, so it's even harder for me to do it in my head. So it's going to be really important for us to do this on paper and make a chart for this. So what we're going to do is, I don't think this will be good for a bar graph because it wants to add things up, or maybe even a pie chart. So I think maybe because it's showing a change in different families, that it's going to want us to make kind of like a line graph, because it is going to show a change in the amount of families. So it says we have 10 different families. So if we just count the number of families, we have 3 families that said they will bring 2 other people. So if we have 3 families, they bring 2 other people, also including themselves, this would be a good time to do some repeated addition or even multiplication. They are the same things. So we could say it's 3 families bringing 3 people. So 3 times 3, or 3 plus 3 plus 3 is 9. So we can write 9 down. And we have 2 families saying they'll bring 3 other people. So it's, because they're bringing other people, make sure we recognize that bringing other people means that they are including themselves in that. So it'd be, instead of being 3, it'd be 4 people. So we'd have 2 times 4 is 8. So then we have 5 families. So they will bring 4 other people. And so we'll do because, again, the same thing, they're including themselves, we'll do 5 times 5 is 25. If you didn't follow that, make sure we're keeping up with practicing our word problems. I know this is just using different types of graphs, and we should be practicing our multiplication and word problems and figure out what is the question asking, what information am I being given. So all we have to do for that is just add those up. So 9 plus 8 we know is 17. And then 17 plus 25 would be 42. Oh, and I forgot a family. One family says they will bring 5 other people. So one family is going to bring 6 people. So we already have 42 for the different families. Then we add 6, so 42 plus 6 would be 48. Alright, for number 3, your room gave you 100 stickers to share with your class. So we have 100 stickers. I think that'll be important. Because you know there are 20 other students in your class, and you know how many each student will get equally, and we know that by just doing 100 divided by 5, or you can do 20 times what gives us 100. And since we know 2 times 5 gives us 10, you can just bring down the 0, so you know 20 times 5 equals 100. However, when you are passing your stickers out, 7 students say they do not want any stickers. If you don't give those students stickers, how many stickers did you pass out? So this will be good for a pie chart, I think, because we're having a percentage of students that are going to be passed out stickers and the students who say they don't want it. So if we made a pie chart, we had 20 different equal pieces of 5 stickers. What we're going to do is we're going to take out 7 of those equal groups. So then if we just do, we can do this 2 different ways. I'll go off the way. If we do 7 times 5, because then everyone's going to get equally 5 stickers. 7 kids don't want it, so we'll do 7 times 5 equals 35. If you need to check that, you can check multiplication chart or do your strategies on paper just to make sure that what we're doing and the answers we're getting is what the answer is. So then, because 35 stickers aren't going to be passed out to students who aren't going to want it, we can just do 100 minus 35 and get 65. If we do 100 minus 5, 95. 95 minus 30, 65 is a quicker way that you can do it in your head, but still it's good to test it out on your paper and make sure we're practicing our skills even if we know the answer. So we know that 65 stickers were passed out. And that's what a pie chart could show with you taking around the 7 pieces. So you Xing out 7 equal pieces of 5 stickers to better show, and that's the kind of work I'm looking for. For this last one, I would like you guys to do that by yourself and send me a picture of the work you've shown by making a graph of the information and the answer inside the graph. I hope today you've learned something about the different types of graphs, and we'll definitely be using this in later classes in our classroom. And just in doing your own things outside, these are very helpful to help you work out word problems and better be able to visualize what exactly am I looking for and how can I go about solving this. So I really appreciate you guys coming to this lesson. I hope everything is well, and I look forward to hearing from you later on. Thank you.